Hi, in this first part of the lecture we're going to create our dome object, and for that we're going to start with a profile by using an L system. So with pressing Control the L system, I have this first tree. I'm going to rename this to Arabic domes, or well, I call it more shapes, because I probably will be able to use them for different kinds or different things as well. So go inside, I have my L system, and let me first delete all of this. And I'm going to create like a profile, a basic profile, actually the same like I've done in the class with the example of the Roman arena. So first I make a premise of one letter A, and the A is going to be replaced by forward going plus, forward going minus, and then ending with A again. So every generation we're gonna get something new. So first of all, I need to change within the values the angle. So the angle is going to be 90 by default. So right now, if I play over here, I have these growing values. Now, there are a few things that I don't like as much. Well, you could use something like this. It is quite easy, but often I like a slider more. So I'm going to show also something quite different. Things that you can do to customize the systems you're working with. For example, right now I have just this generation slider, which is a floating point, and I want to work it like an integer, and I also want to have like a bigger range to play with. So if you go over here, the first one is edit parameter interface. Now that brings up like this whole panel, and the nice thing that you can do is you can check out the complete structure of this node. So you see all the folders that we have. So as we can see over here, geometry is the first folder over here, and the generations, we can find generations over here. So right underneath of the generations, I'm going to add not a float but an integer. So I'm just dragging it up right to here, and I'm going to rename this one to Eugen, which is the short label that's going to be used, or the parameter name that's going to be used if you're creating expressions. And I'm going to create like a nice readable label, like user generations. Okay, so a few things that I want to change as well. I want to add a little bit more in the range, so I can have like 100 generations easily just by sliding down. Okay, now the only thing you need to do is to accept it, and you see you have like a new slider right in the middle of the existing interface. So the thing I'm going to do right now is I'm going to control the generations with this user generation thing, and just by selecting the number and with a left mouse button, you can click it and drag it up to here, make it a relative channel reference, and as you can see, it is using the name that I've created. So right now I'm able to play much easier, and it's not having that annoying grow function. So you can make whatever you want out of it, that's up to you. At least this is something I'm using for now. Okay, so this is the first part. Now the thing that we want to do as well, we want to create some interesting shapes and variations. So those domes, they can exist out of like rounded shapes. We can have like inset curves like this. We can have like even small, all kinds of variations of shapes basically. So the thing what I'm going to create right now is I'm going to add several possibilities, several curve types. So changing this one to B, a number that I'm not going to use, and I'm going to create like a completely new one, and that's just for checking out the shape. So the first one is going to be the function f, and f is going to be turned with 15 degrees, and then f again. So I'm going to just copy this part and paste this for 6 times, so that we have like a nice 90-degree part. So change this back to A, and you see we have this nice turning curve. Now the only thing I want to make sure of is, let's say if we put A behind, well, it just continues on turning, and that's not what I want. So we'll make a minus rotation of 90 degrees into the other direction. The reason why I'm doing this is because each one of these rotations adds up to 90, and I have to counter this rotation back again to 90, so it can start off with exactly the same orientation as which is started over here. Let me create just one other shape, or no, I can show it right now what we're going to do. So we have both things. We have either this shape or either that shape. The thing that I want to change right now is I want to have like a random variation that sometimes either this shape is going to be used and sometimes that shape is going to be used. And in order to set a randomness, the only thing you need to do is to add behind the rule a double point and then set a number from 0 to 1. So I'm going to give each of them a 50% chance. So first you have 3 of this one, now 1 of this, and then again. So this is just saying, okay, this is random chances. Now those randomness, it is controlled over here. So if you play around with the random seed, you see you have all kinds of variations coming up like this. Alright, so what's more, again I have the same problem over here with the random seed. I have only like 10 variations. That's really not enough for what I want. Well, the thing I'm going to do now, I'm not going to create like a new slider, but I'm going to connect the time to the random seed, and for that I'm going to use a variable $f is the name. So right now if I use this, you see all this randomness is going on. Okay, so if you want to know all these variables, I've shown you in the last one where you can find variables of geometry. Let me show you some other ones as well over here in the Houdini. You have the expression functions. I'm not quite sure they're over here. Global expression variables. This is the one. So as you can see, the play bar variables, these are global, and this means you can use them everywhere, not only within modeling but also within compositing and all those other things, which I'm going to show you later on. And right over here you see $f, the current frame, as set with the play bar controls. So the same thing over here, you have a floating point version, you have also just an integer version. Right, so now we have these variations. So we're going to make it much more interesting by creating all kinds of varying shapes. So let's go back to those rules, and I'm going to set those back to B again, so it becomes quite easy for me to check out various examples. So another one might be that it starts off right with plus 90 degrees, sorry, plus 90 degrees and an F. So as you will see over here, see this line starts off right like this. So again, I think what I'm going to do something similar as I did over here, but instead of using clockwise, I'm going to use counterclockwise versions. So this gives me something like this. Okay, and we will end again with an A, and so we'll have quite the opposite shape. So again, we can do over here a 0.5%, but this is not going to work very well. I'll show you immediately. The problem is that the randomness is each time being eaten away, so it adds up till you have one. So over here 50% is being eaten away of your randomness, and then the other 50% is being eaten away, and you have nothing left to do randomness, so it will never reach to this formula. So best is to either equally divide the randomness, or do whatever you want to get the shape. So over here, let's say I'm going to change this right now to 3, 3 and 4, and now we will be able to see like a combination of all of these shapes at the same time. So this is going to be the result. So we can continue on for a little while. I'm going to create again a few of these, but you have to make sure, as always, that the end result of your line, or the end result for the next line, is going to be the same direction, so that you will never end up with getting into problems with it. Okay, so I'm going to copy this one and see what this result is going to look at. So over here I have to add the plus 90 at the end. So this is going the other direction, and I'll do exactly the same for this one. A, and over here the minus 90 degrees is going to be ported to the front. So get it away and put it over here. Let's see what we have. Alright, so we've now all kinds of variations. So let us check if we have now 5 rules, and we copy these rules over here again. So right now we have a constant randomness for 5 rules, which adds up to 100%. So this will add up into all kinds of interesting shapes. which at the end can be revolved. So I'm going to add some more detail like this, and we have all kinds of nice candle shapes and so on. Sometimes they're inverted, sometimes not. Well, let's say that we do invert those shapes. Let's make something like this. Reverse. This will reverse the normals of the shape. And now we have all kinds of basic random shapes that might be interesting to be used in something. But we're not quite there yet. I mean, we can just go on adding those things. One thing which is important, it still doesn't look too much like a dome. We have all kinds of shapes, but still not dome-like shapes. So I'm going to do something with this L system, with this shape. So I'm going to take at all times the most sideways part of the shape and just move it to the middle, so we get a better revolve. So let's see what is the result going to be over here. This is the result. And sometimes it goes to the other side, and that's not what we want. Okay, so I'm going to make sure that this part is always going to be at the middle. So therefore I'm going to use a transform node. A transformation. And what I'm going to do right now, I'm going to use an expression again, and therefore it's really important, I can't stress this enough, that you often read the expressions. I mean, there are too many, I can't explain them all. This is something you have to study yourself. I mean, there are all kinds of expressions, and best way to learn them is just to go in there and try to see what they can do. And if you see what they do, then you get a little bit of an idea what all the possibilities are going to be. Now we're going to use this one, the bounding box. Returns bounding box information of surface node. So how do we need to use this? So we have to say, okay, bounding box. Then first of all, we have to type which operator we're going to use, and that's going to be the L system itself, and then what exactly that we need. So are we going to use the X minus channel or the X maximum channel? So I think we're going to use the X minus channel. So we want to see how much the object is on this side, and we will use that value to move it back again to the center. So over here in a bounding box, we go to the translate X, and I type down this expression, which is already nice auto-completion for me, double point slash, and I'm going to select right here the L system 1, comma, and now I'm going to choose what I'm going to use for that. The min, and I have to use, of course, also the X channel. So if you check it over here, we see a value. Now, right now it's doubled to the other side, so that's not exactly what I want. So for this I'm going to use the negative of the bounding box. Something like this. So right now I have all these nice shape-like structures. And always nicely placed right in the center. Now I'm going to add just some more, but the only thing is I want to make chances slimmer for shapes turning into the other way, so I'm going to add just ones over here and add trees over there, so chances are going to be bigger that we have this upside down kind of shape. Well, it's not what I had in mind. Oh yes, of course. Now, as you can see, chances are bigger that the object is going to be like this. But when I do this, I'm going to change the operation over here. I'm going to use this part as a center. So I'm going to use x max. Oops. X man doesn't exist. Right over here. Like this. So right now all my shapes are more, they have a bigger chance of being like this dome kind of shape. So this is one part again. A few other things that you can do as well, and that's it. That is that we can add a size over time so that it gets smaller each time it's going to be used. So over here I'm going to set a double point, an exclamation mark. No, sorry, not an exclamation mark, a quote mark. And the quote mark will make that it's getting smaller each time we have a generation. So that should happen for each one of those. So when we see this, now we have each generation every time a smaller function, which again adds to the dome-like effect that we want to have. Perhaps right now the dome effect is a little bit too much. They always look like a pile, look like a pie. Well, it might be not very clear what this function does, so it's a scale over time. I'm going to make a copy so that you can see exactly what it will do. So let's have this new L system, and let's make it just very simple and clear by only using one rule, which is going to be this rule. And so now you can see it. So the quote mark means that for every generation being created, the sizes are going to be multiplied with the step size scale. So this is also very good if you make, for example, a rule in which you go like a spiral inward. you see, then you have like a scaling in which it will be always smaller and smaller. Like this. Okay, so right now we have this on our shapes right over here. But again, this, like I say, this is something that you may want to tweak several times. So right now we have 3311, and because I did the scaling, I do think it might be better that we give them some kind of equal chances of being there, and we get something more like this, so that we have all these variations that we want to use. Again, I'm going to add some other rules as well. So we go to rules 2. We can continue over there. So A is going to be, in this case, just one straight F upward, and we're going to give it also a random chance of being there. 0.1, and well, some other ones that are also interesting. A is going to be F. I'm gonna make this a longer one. No, just keeping it like it is. F is going to be a rotation to the positive sides, more to the beginning, positive side of 45 degrees, and then we have a minus of 45 degrees. So for each operation, like I've told you before, is that you can have like a plus, and if you don't add anything behind brackets, then it's using the default value, so the angle of 90 degrees, but you can overrule those by just adding brackets and changing those. Okay, so going to add this to 0.1% of a chance, and again, you have to give it a little bit more probability of being there, so 1.15, 1.15, 1.15, 1.15 chances of being there. Oh, quite important, of course. Always have to end with a previous version. And the more variations you have, of course, the more of these results you're going to have. Just fiddling around a little bit more, I'm going to change this to FFFF, making like a very long one. Something like this. Start to get all these nice shapes. Okay, so this concludes it for the first part. I'm going to continue with the second part.